Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at angles of elevation and depression. What we're basically doing here is using trigonometry to take a three-dimensional problem, represent it in a two-dimensional way, then use normal SOHCAHTOA to find lengths or angles. So what is the angle of elevation and depression? So if you have something like this, a cliff here, you have something here that's on top, the angle looking down is called the angle of depression. So the angle looking down from the top of a cliff to, say, a swimmer in the ocean, that's the angle of depression. The angle of elevation is the opposite. It's the angle looking up. It's the angle from the swimmer up to the cliff. Now, I've used theta to represent both of these angles because even though these are different concepts, they're always equal. If the angle of depression from the cliff to the swimmer is, say, 30 degrees, then the angle of elevation is also 30 degrees. These two are always equal because they are alternate angles. So note a very important point: the angle of depression and elevation are always the angles made with the horizontal. So of course horizontal goes this way. Angle of elevation is this made with the horizontal. Angle of depression is the angle made with the horizontal. This angle here is the angle made with the vertical cliff, and it's not the angle of depression and elevation. Really important you don't mix up these two angles or you'll get the wrong answer. So let's look at a question involving angles of elevation and depression. So from a point 30 meters away from the base of the building, the angle of elevation is 40 degrees. Calculate the height of the building. So if you are not given a diagram, let's draw one to see what's going on. So what happens is we have some building here, I'll just call it B. So then we've gone 30 meters from the base of the building. We can assume the building is at right angles to the ground, and we're told the angle of elevation is 40 degrees. So we need to turn this into a right-angled triangle. So the angle of elevation is always the angle here made with the horizontal. The angle of elevation is the angle looking up, but it's with the horizontal. So it's this angle here that is 40 degrees. So once we've drawn this triangle, the hard work's done because we know how to find sides really easily. So here we have an angle. We're looking to find the opposite side when we have the adjacent. So SOHCAHTOA, we use tan. Tan involves opposite and adjacent. So we have tan of the angle equals the opposite side over the adjacent side. When the thing you want to find is on top, you multiply. So here the height of the building is just going to be 30 times tan 40. So put that on your calculator, making sure it's in degrees. So putting that on our calculator, get about 25.17, and it's in meters. So the building is about 25.17 meters. So this shows where trigonometry can be used in real life. It's not practical to measure the height of a building. It's really easy to measure, how far you've walked from the base of a building, and you can easily measure angles of elevation and depression using a clinometer. So that allows us to calculate the heights of things that are inaccessible. All right, let's now look at a harder question. So from a cliff 30 meters high, two swimmers on the same side of a cliff need to be rescued. Angle of depression to the swimmers is 30 degrees and 72 respectively. How far apart are the two swimmers? Okay, so this is complicated. To try and do it in your head is going to be hard. Let's draw a diagram to see what's going on. So we have a cliff here that's 30 meters high. Then out here we have two swimmers. So what we're going to do is just draw a line between these two swimmers in the ocean, swimmer 1 and swimmer 2. So the angle of depression is 30 degrees and 72 degrees. So remember, the angle of depression is always the angle made with the horizontal. So we're going to draw a line out here to the first swimmer and a line out here to the second swimmer. So the angle of depression is this angle here. Obviously this angle here is smaller, so this will be the 30 degree angle and this will be the 72 degree angle. So we're going to assume that the cliff is at right angles to the ocean. So remember what I said before, the angle of depression and elevation, though they're different concepts, they're always equal. So if this angle here is 30, so too this angle here is 30. They are actually alternate. And similarly, this angle here is 72 degrees because they are alternate. So what we have now is we have two right-angled triangles. Each of them has an angle other than the right angle, and it has a side. So we can calculate any unknown sides or angles in these triangles. So we actually want to calculate this distance here. So that's a bit tough because this is not a side in any of the right-angled triangles. But what we can do easily, we can calculate this length here, which I'll call x. We can easily calculate this length here, y, and we simply subtract to get this length here. And that makes sense. The distance between the two swimmers is just how far this one is minus how far this one is. So let's start by calculating x. We have a right-angled triangle, an angle, a side. So once again, we have opposite and adjacent, so we need to use tan. So tan of 30, tan of angle, equals opposite over adjacent. So when the thing you want to find is on the bottom, remember you divide. So x is actually 30 divided by tan 30, and then we put that on our calculator. So we get about 51.96, and of course that's going to be meters. So this swimmer here is 51.96 meters from the base of the cliff. So now we're going to do something similar to find y. Once again, we're using tan because we have opposite side and want to find the adjacent. So this time, instead of using tan 30, we use tan of 72 equals opposite over adjacent. So once again, the thing you want to find is on the bottom, you divide. So y will be 30 divided by tan 72. So we actually get about 9.72. So this swimmer here is 9.72 meters from the base of the cliff. So this distance here, the distance between the two swimmers, is simply 51.96, how far away the first swimmer was, minus how far away the second swimmer was, and you get about 42.24 meters. That's the distance between the two swimmers. So this will be helpful in a rescue situation. If you knew the height of the cliff, you could easily measure using a clinometer the angle of depression. So you could calculate the distance between these two swimmers really easily. You could do it without actually having to go into the ocean and calculating the distance, because that would be pointless. If you were able to get down to the ocean to these two swimmers, you wouldn't even need to calculate the distance between them. So really important, angles of elevation and depression, they allow us to calculate lengths, angles of inaccessible objects. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.